Okay, welcome. For this video, we're going to be covering some more advanced functions of animating inside of 3ds Max. In the previous video, we created a simple keyframe animation using our auto key feature inside of Max and animating along the position, the rotation, and the scale. So we're going to build on that in this video by introducing a couple of concepts. We're going to be introducing and talking about hierarchical linking. And we're going to be replacing that default controller with our animation constraints. So I do recommend that LinkedIn video that I had posted kind of to our shell. If you're watching this just through YouTube, LinkedIn Learning has some really amazing video tutorials on animation, as well as, of course, as YouTube itself. So let's just jump right in. So for this, first thing I'm going to do is I'm going to create a really basic animation rig. So to help demonstrate this, one of, I would say, probably the most common models I've seen used for an example for this type of animation is sort of like a turret-like design. So that's what we're going to create. So I have two models here, and I'm going to work in perspective view, even though I said working perspective view isn't always recommended, just so you guys can see what I'm working on a little bit easier. So I have a tube I've created, I have a sphere. If I wanted to, I could even use some of my advanced stuff, like come up here to my align tool and click on the sphere and make sure that the X and Y position are kind of centered. I don't necessarily want Z because I don't want it to drop down, and I'll hit apply and hit OK. And so I know that both of these objects are directly on top of each other. Next, I'm going to come over here and use the linking tools. In the upper left-hand corner, we of course have our undo and redo buttons, but next to them are our link and unlink tools. So hierarchical linking basically creates a relationship called a parent-child relationship. This is kind of our foundation for all of our advanced animation rigs. How it works is wherever the parent moves or looks at or does, the child is affected. However, the child can be animated on its own. The child's animations, while don't affect the parent directly, they are still linked and tied to the parent. So to kind of explain that and show that a little better, I'm going to click select a link, and I'm going to click on my tube because I'm going to link my tube to my sphere. So I'm going to click, I'm going to drag. Notice it created this little like linking tool and this little chain, and then I'm going to hover over my sphere and let go. What that's going to do is link these two objects together. Now, my sphere is the parent, my tube is the child. If I go back and use my rotate tools that we did in the last video and move this sphere around, you can see the tube goes everywhere with it. Now I'm going to hit Control Z to undo that because I want to keep it perfectly aligned. I could have come up here like we did in our last video and turn on angle or percentage snap to make it easier to see how much. But for that example, I just wanted to move it around to make sure it was working. So you can see wherever the sphere looks, the tube will look. I made the tube attached so we can kind of see this in action. So this is what we're going to be using with our look at constraint. So we're going to make this object look at something. So let's create something fun for it to look at, right? Now I'm just going to come over here and I'm going to go to my line tool and I'm going to switch back to my quad view and I'm going to go in my top view for this. Remember, a lot of times it's easier working in these orthographic views. I always recommend working in an orthographic view if you're modeling or creating something. Don't ever make anything in perspective unless you are very proficient in the software. And even then, I've been using this thing for 20 years and I don't hardly make anything in perspective unless it's something simple. So you can see here, I'm going to go to my top view and I'm just going to create kind of a basic line. Now if I want, I can even close this line and hit yes. So I've created kind of this simple wiggly shape. I'm going to go ahead and also in perspective view or one of my orthographic views, for this one doesn't really matter, I'm going to move it up because I want it higher above this thing, at least to there. And then we'll zoom out a bit so you can see it all. All right, let me pick my spline. Now, you probably noticed when I first created it, but if I come in here and click on like one of our sub-objects, you can see, notice this vertex is yellow. Now, if you don't remember this from learning some basic 3D modeling stuff, I know for many of you it might have been a while since you learned basic modeling in Max, that yellow vertex means it is the starting point of our line. Now, we did close our line, so even in a closed shape, there is a vertex that is defined as the starting vertex. When we start using these lines as path constraints and different animation tools, that's kind of a big deal. That's super important. When you're just like creating a model out of it, it may not be important which vertex is your starting vertex. In a closed shape, you can define a different vertex or vertice as the starting one. So if I wanted this to be the starting vertex, I could, for example, right-click and go in here and click Make First. And you can see now that's the yellow one. Although if I do that, I definitely want to come back to this one and change this maybe to, smooth. It still doesn't look that great. Maybe we'll do a Bezier so we can get a nice smooth edge. All right. Again, it doesn't really matter for this example which vertex is my starting one, because for my animation, I'm going to create an object that goes along the path. If you're doing something like a racing animation, if you're doing something like a roller coaster, there are so many cool ways you can use this tool to create a very complicated animation that would otherwise be almost impossible to make. Again, if I wanted to animate a roller coaster going through a loop-de-loos and a round thing and all that crazy stuff, it would take literally like so long, like a mind-numbingly amount of time to try to make sure that roller coaster ran on that track, right? Because of course, if it's not running on the track, it's not going to look realistic. Using this method, you could even generate the track itself from the splines, if you think back to 3D modeling, and use that same spline for not only the model, but also for the animation. So you can have the exact same one. Again, I'm getting ahead of myself, but I get excited about stuff like this. All right, so let's come over here. The other thing I want to do is, while I could use a box or another one of my primitive objects for this. So if I wanted to create a box, I could do the box as a object and animate it along here. But for this video, and because I know some of you are really excited to learn this stuff, I want to show some more advanced things. So I'm actually going to come over here, and I'm going to come over to, let's see, where is that? Helpers. And under Helpers, we have Dummy, which is our first one. Now, a dummy object is basically an object that has parameters and properties, but does not render. So you can see I've created this dummy. It's represented as a green box. A dummy object is such a helpful animation tool because it's something that you can animate, you can link things to, you can work with without actually having to animate the object itself. Now, I know we're first starting out, so you haven't done a lot of animations yet, but I'm wanting to show you this to kind of save you time later. By putting animations on something like a dummy object, you can do all kinds of really cool advanced things. Like if you wanted to, you could animate it, an object transitioning from this path to another path, or things like somebody picking up an object or setting an object down or moving an object from hand to hand, and all kinds of neat things by utilizing these dummy objects. So as we get into more advanced animations, you'll see what I'm talking about, but I thought it'd be fun to introduce it even in this example instead of just using a box. So I thought maybe it makes it a little more fun. Using these non-renderable animation tools. The spline also by default, unless you turn on rendering, doesn't render. So when I render this scene, you can see all you see is my object. So you can use all these fun things together. In fact, if you ever watch some behind the scenes videos from like Pixar and different animation studios, you'll see they have dummy objects and animation controls all over those characters. Little sliders that animate their face, little elements that help animate their elbows or open and close fingers, all kinds of stuff. And you can do all that stuff in Max. You can create all kinds of sliders and different tools to help you with those complex animations. All right, so I'm going to grab my dummy object here, and we're going to animate it first. The reason I'm animating it first is because I'm going to use a path constraint to animate this object to move along the path. Then I'm going to use a look at constraint to make this other object I've created watch it. If you look at our assignment, that's basically what we're doing. I have some videos in the assignment that kind of showcase the same thing. Again, I don't want to say that my video is the only one or the best one out there, but I want to kind of show you how to do this myself too. So for this, now that we're creating an animation that we're not animating by hand, we're going to come up here to animation. The animation panel, or rather menu, has all kinds of information. Just like when you were taking 3D modeling, I want to reiterate, there are so many tools in Max. It's so easy to get overwhelmed when you look at these menus, but if we take them piece by piece, utilizing the tools we need and not worrying about all that extra data, it doesn't have to be as intimidating as it seems, okay? So for this, we're going to be looking at constraints. So if you look, here's where you can find controllers and constraints. Now, constraints and controllers do kind of similar things. A controller will replace the default controller, which is the default thing that makes you be able to animate. So there are transform controllers, there are position controllers, there are rotation controllers, scale controllers. So a position, rotation, and scale controller are elements that control those things. So if you did, like, for example, an audio controller on scale, you could play an audio track and the scale would change based on the waveform. Things like that. And you can do all kinds of cool stuff in each of these specific pieces of the animation. A transform controller controls all of them. So, it's something that's going to kind of replace the entire transform controller or default controller. So constraint is what I'm looking for this. Again, you can see both the ones we're going to be playing with in this example are constraints. So I'm going to do path constraint. Now, if I come over here and look, we can see again my controls, my settings and stuff. Notice kind of the string. It's wanting me to pick my path. So I want to just click on it. So it's happy. It doesn't like me exploring the menus while I'm trying to do something. So you can see once I click that path, and down here in path parameters here, I can delete the path or add path. So if you clicked on the wrong one or you're not happy with it or what have you, you can delete or add it easily once you've added that constraint. So if you have more than one, you can do that here too. Notice by default, again, the red little bracket here, and it has created some little gray shaded keyframes down here. Now, in the last video, I showed you the keyframes were red, green, and blue. Now they're black or gray. That means that what we're animating is not position, rotation, or scale. It's something else. In this instance, it's animating a percentage along the path. Now, by default, Max will create your animation to start at whatever your timeline starts at, in this case 0, and end wherever your timeline ends at, in this case 100. This is probably fast. If you wanted to slow it down, you can manually move the keyframe or manually change the percentage along path value at a different location, or you could create and change your timeline first. Let me hit play though and watch what happens. Again, by default, it's using the entire timeline to create a uniform animation of it moving around the shape. Notice it started from the vertex that was colored yellow and goes all the way around it, taking the entire 0 to 100 keyframe time. And you can watch here along the path as it goes from 0 all the way to 100. All right. So you can continue to kind of tinker with this stuff. The other thing I want you to know, by default, it put the weight as 50. We can actually have this thing weighted between multiple paths. So you can actually add some variety and variation to some of your objects. So if you wanted like a whole V-shaped formation of ducks flying, you could add a couple of other paths to make some variation in flight between specific ducks while making them all follow the same path. Things like that. All right. So you can see how easy it was. Literally, I just clicked path constraint and clicked on my spline. It took longer to explain it than it did to do it. All right, so I'm going to come back and I'm going to grab my sphere. And I'm going to put it back at 0. And I'm going to come up here to animation, constraints, and I'm going to do a look at constraint. And again, it's creating that chain. It's the same process for linking, right? So that's why we wanted to do the linking first. So I'll click on the square, and it will automatically follow and look at it. Now, I want you to notice it's wrong, right? It's broke. I mean, it's working, but it's not looking the way I want. That's why I created that tube, is I wanted you to see I have a specific direction that's supposed to be looking through, and it's not set up right. So that is crazy common, right? It's super common. So this happens all the time. I don't want you to freak out or get discouraged if your object is not looking at the object from the right angle. Now, the wrong way to fix this would be to edit the model itself, actually turn it or move it or any of that nonsense. We don't want to do that. That would require tons more work. What I want to show you is you can actually play around with the orientation over here. Okay? So we're going to change these settings till they're right. So you can see here is my object. Here it's facing definitely the wrong way. So let's play around. So first thing you can do is you can set the look at axis. So feel free to change it from X to Y to Z. Oh, looks like it already fixed it. You can also click flip and see if that helps. Okay, again, it looks like very easily, if I do Z, it's fixed. So you can see by changing the look at axis, you can kind of play with it a bit. All right. This is also why when we model things, we want to make sure that they are orientated correctly. In the 3D modeling class, we don't really worry so much about which way is up. But when you start doing animation, that's vitally important. The one thing to never forget when you're working inside of 3D, that's super easy to forget, is you're working with math. This is a computer that's calculating math. So it is calculating the rotation of this object and modifying its rotation based on the location of that box. And so as that box moves through XYZ space, the rotation of this object will mathematically change to match it. Now, I have students all the time that don't love math. If you don't love math, that's okay, right? You're working on a giant calculator. This sucker does the math, and you know what? Computers don't like anything more than math. That's literally what they're made for. So, I'm not asking you to calculate the equation of tracking this box. You could, but I want you to remember that we're working with math. So if you're a D&D person, think of it like the difference between a wizard and a sorcerer, right? They're both using magic, but where a wizard has to study in the books and prepare their spells, the sorcerer's powers come innately. So in this, we are utilizing math. We're not doing the calculation. We're letting the computer do it. But we have to respect that math and understand that these numbers are going to be adding up. So when something is funky, when something doesn't animate right, when something is driving you nuts, I hate to say it, most of the time it's because something you've done is making the math not add properly. I know that's not great to hear, but what's helpful is knowing that you can go back and try to troubleshoot what's wrong. You know, what's almost always the problem is something wasn't correct math-wise. An object wasn't facing exactly up or exactly front or exactly however orientated it needs to be. When it was modeled, it was off. When at some point somebody turned it and then reset it so that way its center isn't center anymore. Or an object was scaled and you don't know it's scaled, and so that scale information is being calculated. There are examples of, even from Toy Story, things like the bones getting really long and looking weird. And almost always the reason why that's happening is because some scale value got messed up. Somebody scaled something, didn't know it was scaled, and so there's some variable of math that's being added to everything that's messing up the whole thing. All right. Again, I'm not trying to scare you away from animation, but I want you to understand that when we're doing all these things, what we're doing is we're calculating those those geometries that change in location within three-dimensional space. So while it's as easy for us as clicking and dragging on a line, it's important we recognize that, because if you're having some funkiness with it, it's probably what it is. Okay, so again, I'm going to play my animation here. I'm going to end this video. So this is pretty much using our path constraint, using our look at constraint. What's neat is if I rendered this, you wouldn't see that line or that box. But we could easily add something so you can see it. So if I wanted to, again, I could create I don't know, we'll do teapot, because why not, right? So if I want to create an object, I could use my align tool and align that teapot to that box. And I could use the link, and I could even link it to that box. Now what's cool is, you know what, since I'm doing this anyway, we could even do something like grab the teapot and go to constraints and do like a link constraint and constraint to the box. Now for this example, we don't really need to do that. We could just do normal linking. But what's cool is, and I want to show you, the link constraint works just like the link, but unlike the regular link, you can actually unlink it at any time. So if I wanted the animation of this guy, again, we're going a little beyond, but that's all right, right? You can see here, because I clicked the link constraint on frame 16, I didn't go all the way back to the beginning. We might want to move that keyframe back to 0. It's also why you should start at 0. But if I wanted to go, let's say, to frame 70, I could do link to world and check this out. Boom, it lets go. And see how kind of easy it is. This would be super hard. Like, again, if you were animating this by hand, this would take you hours and hours and hours. But using these amazing tools like look at constraint, like path constraint, like link constraint, I can do something like have this box pick up that teapot when I want it to and drop it when I want it to, just like that. All right, hopefully you guys all have fun animating, and let me know if you have any questions.